I did a little bit of research on sorbic acid, the molecular structure here, and it's interesting. They gave the name of it as 2,4-hexadienoic acid. Hexa, we've got 1, 2, 3, 4, 5, 6 carbons, so that's good. And here's our COOH, which is our acid. And the 2,4-DIE means it's got a double bond on the second carbon and on the fourth carbon. Got 2 double bonds on it. But here they give its actual formula, and it's a white powder. But I was surprised to see this moldy bread here. It's called sorbic acid rather than hexadienoic because it was first found on a tree that has the Latin name sorbus, and hence this is the acid from the mountain ash, which has got the official name sorbus. A lot of berries have acid in them, so these berries got to be pretty sour. They've got an interesting antibiotic property that they end up stopping lots of molds. If you've got, let's say, a ham that you're going to be shipping somebody, you can dip it in a sorbic acid solution and it won't grow mold on the outside for a month. And if you have a little bit of bread, the bread won't go moldy. And it's a plant product, so that they can say this is all natural. It's supposed to be one of the best antibiotics for the botulism bacteria, which is like one of the worst poisons that you can get in food. Sorbic acid will stop the botulinum organism from growing in your food. It's been saving our food so it doesn't get moldy. Okay, now let's get to the problem. B is a pretty straightforward one. It's a question where we have our sorbic acid. It's here. We've got our 45 mLs. Let me get my little green highlighter out. Here, you can see it now. We've got it's really colorless, but my color code for the acid's green. We've got 45 mLs in it. We have some base, which is the sodium hydroxide. This, you could probably even drink this if it was food grade, but you wouldn't want to drink the sodium hydroxide that's here. Here's my highlighter. And I'll switch over to, danger, Will Robinson, our sodium hydroxide. Super caustic stuff. Just touching this stuff, your skin will feel slippery. It actually changes the oils on your skin into soap. That's why it feels slippery. It's not very painful, which makes it dangerous, but it is extremely caustic. If you want to dissolve something, even hair, sodium hydroxide is the thing to do. We've got it in a burette. Burettes are old school. They're still going to be used in colleges, I think, for the next 10 years or so, but everybody's going by drop counters now. And we're starting off with our burette filled up to, not to the 0 mark. The burettes are weird not weird, but they're logical. They start off at 0 mLs at the top. So I've got, 0 up here. So if we're starting at 0 and we move down, this line right here, I'll get my arrow pointer, is that line right there. The division is going to be 0.5. And this is 1 unit beyond that, 0.6. And it's between the 0.6 and 0.7. So I would estimate, remember, you always have to read between the lines. That's our little rule. And so we're going to start off at 0.6 tenths because there's the 6 tenths mark. And we estimated 5/100 ml. On the test, they'll give you some leeway. You could put down 6.6, 6.7, 6.3, because that is an estimate. So we're starting off with 0.65 is our marker. And then we end up going to our new position. It's between 21 and 22. And it's right at that, let's see, 1, 2, 3, 21, 1/10, 2/10, 3/10, and it looks like it's right on the line. So I would say this had dropped down to 21.3, but you have to say, I know that's almost exactly on the line. You have to put that 100th of an ml in. In fact, 1 point on this test that this question came from was if you estimated the hundredths. Our net volume is going to be a subtraction of these two here. And let's see if I can drag my calculator back up into the screen. Here's my calculator. Or wait a second. I've got Alexa. Alexa, 21.3 minus 0.65.
21.3 minus 0.65 is 20.65.
Okay, Alexa, and my calculator would say the same thing, is going to indicate that my volume that was dispensed going from here to here will be the difference between these two, which is 20.65 mLs. So you know how to read a burette. And someday your grandkids will say, what's a burette? And you can brag about it, saying, hey, this is how we used to pour out liquids before we had auto titrators. So that's it. That's the answer for B. 2 points. One for figuring out the 2 volumes, and the other point you'd end up getting for getting the right number of sig digs on this sort of thing. So right now, if this were an FRQ, you would have gotten 3 points. You would have gotten beyond the average, 3 out of 10. So, okay, that's it. That's our sorbate. And let me just say this also here right now. I wonder what color I should end up using for my highlighter, because we're putting this in to neutralize the acid. Now, what happened is as we went from 0 to 20.5, there was an indicator here that changed color. And that indicates, hey, you wiped out all the acid because you've added base to it. We'll get to that on the next part. But that's the general idea. You added the base to neutralize the acid. So right now, what's in here is not sodium hydroxide, and it's not sorbic acid, but it's the conjugate base of sorbic acid. Okay, I'm going to